Recall that if we want to calculate Laplace transform of function f, we have to calculate the integral from 0 to plus infinity e to a negative st f of t dt. Often when we try to calculate this integral, it's really difficult or sometimes even impossible to express these integrals in terms of elementary functions. To remedy the situation, if it's difficult or impossible to calculate the Laplace transform directly, we'll calculate Laplace transform of power representation of function, Maclaurin representation of function. Let me illustrate that on an example. Say we need to calculate Laplace transform of cosine of t squared. If we try to calculate it directly, we're going to get difficult integral e to a negative st multiplied by cosine of t squared. So instead, we have to recall what is a power series of cosine. Power series of cosine is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6 over 6 factorial, and so on. So instead of calculating Laplace transform of cosine of t squared, we're going to calculate Laplace transform of its power representation, 1 minus t to the 4 over 4 factorial over 2 factorial plus t to the 8th over 4 factorial minus t to the 12 over 6 factorial, and so on. To calculate that expression, we need to recall that Laplace transform of t to n equals to n factorial divided by s to n plus 1. So we're going to get that Laplace transform of cosine of t squared is going to be equal to 1 over s minus 2 factorial on the bottom, 4 factorial on the top, s to 5 plus 8 factorial on the top, 4 factorial on the bottom, s to 5 minus 12 factorial on top, 6 factorial on the bottom, s to 13 plus, and so on. So that will be Laplace transform of cosine t squared. Maybe I'll do one more example. Let's say we want to find Laplace transform function f of t, which equals to 1 minus cosine t divided by t squared when t equals to not equal to 0, and 1/2 when t equals to 0. So to calculate Laplace transform of this function, we to switch to Laplace representation, to our power representation of cosine t, which is 1 minus t squared divided by 2 factorial plus t to the 4 over 4 factorial minus, and so on, divided by t squared. So we're going to get combined 1 minus 1 in denominator and distribute minus, so we're going to get t squared over 2 factorial minus t to the 4 over 4 factorial plus, if needed, t to the 6 over 6 factorial, and so on, divided by t squared. Distribute division by t squared, so we're going to get Laplace of 1 over 2 factorial minus t squared over 4 factorial plus t to the 4 over 6 factorial minus, and so on. So at the end, we're going to get Laplace of our function. Laplace transform function equals to 1 over 2 factorial s minus 4 factorial 2 factorial s cube plus 6 factorial 4 factorial on top s to 5 minus, and so on. That's going to be our answer for this problem.